Hello and welcome to US Application. My name is Kutemwa Masafwa and this is our SAT crash course. So today we are in the math section and we are looking at all things linear equations. So first of all, we're just going to break down linear equations and look at the main concepts that you need to know, and then we'll look at an actual SAT paper and handle some questions and see how to apply those concepts. So first of all, I want to say SAT math is not complicated at all. It doesn't test complex or deep concepts. It tests the very shallow ones, but then it brings them out in such a way that you really need to understand the concept for you to see how it's twisted. So we're going to just break down linear equations and understand what is involved and what you can get from a linear equation. So the general form of a linear equation is y is equal to mx plus b. Doesn't matter what letter is used here. The point is that this is just a constant. So we have our y, our x, which are our variables. Then we have m, which represents the gradient, and we have b, which represents our y-intercept. So let's break this down. So the properties of a line, you have your x-intercept, your y-intercept, and your gradient. Okay, so your x-intercept is the point where the line crosses the x-axis, which is why it's called the x-intercept. And because any point on the x-axis is y is equal to 0, it means that for you to get the x-intercept, you simply have to plug in y is equal to 0. So that's your x-intercept. Then you have your y-intercept, which is more special and has more applications. This is the point where a line crosses the y-axis, and as we said, this is a constant in the equation. So if you want to find your y-intercept, you simply plug in x is equal to 0, and this has a really deep application. So usually, or let me give an example, right? If we are looking at the cost of renting a boat per hour, you'll find that the cost of renting a boat is on the y-axis and your hours are on the x-axis. So what you're essentially trying to find and measure is always on the y-axis. And so if x is equal to 0, right, it means that your time, because usually what's on the x-axis is time. And you find in most examples that what's on your x-axis is time, either in hours or in minutes, whatever unit that it's in. So it means that if x is 0, then your y-intercept is going to be your initial, right? So if we're saying that it's the cost of renting a boat per hour, it means that if the number of hours is 0, it means that you haven't yet started. So it would be like some sort of base payment, right? Before you actually start counting the time, that's going to be your value of y, the cost that you're going to have to pay. So you meet a lot of questions asking you, they'll give you an equation and then ask you what the constant is in real life. So just remember, whenever you see the y-intercept, it's going to be your initial, your starting point before you start counting time. That's going to be your y-intercept. Okay, then you have the gradient, which is very important concept. So the gradient is the steepness of a line, and there are two ways of finding the gradient. So you have the formula y2 minus y1 over x2 minus x1. So if you obviously this formula only works if you have 2 points on a line, so you have 2 sets of coordinates, then you can use this formula to find your gradient. Okay, so the important thing to note, something that can help you solve faster, is that if a line goes through the origin, you can simply find its gradient by saying y over x. And I remember meeting a lot of questions that could take advantage of this concept. So where does this come from? Okay, so in finding the gradient of a line, it does not matter which points you choose in the line. You are still going to get the same equation as long as those are 2 points on the line. So if you know that a line goes through the origin, you can assume that one of the points you're using is the origin. Okay, so let's assume we have a line that goes to the origin and then goes through 2, 1. Those are the coordinates that we're going to use. Okay, 2, 1. So if we're using this formula, y2 minus y1 over x2 minus x1, and we're using that point and the origin, it's going to be 2 minus 0 over 1 minus 0, which is still 2 over 1, right? So it means that we can simply find the gradient by saying 2 over 1. So this comes from you being able to use any 2 points on the line. So you assume that one of them is the origin, and you use that point, means it's just going to be y over x, because the 0, 0 is not going to have any effect in this equation. Okay, so whenever you have a line that goes through the origin, you don't need 2 points to calculate, you just need 1. And you say y over x by assuming that the other point is the origin. Okay, so make sure you remember this, it's a very important concept. And then the other way that you can find the gradient is by making y the subject of the formula. we already looked at the general form of an equation, right? Y is equal to mx plus b. So it means that whatever equation you have, if you arrange it in this manner where y is the subject and x is on the opposite side, then the coefficient of x is going to be your gradient. Okay, so it means that if you have the equation of a line, you can simply find the gradient just by rearranging it. That's if it hasn't already been rearranged in this order. So it's not always that you have to actually calculate the gradient of the formula. Sometimes you can approximate, and this is the goodness of having a multiple choice, exam. Okay, so the 5 important points that you need to know when it comes to approximating your gradient. The first one that you need to know is when the gradient of a line is positive, it's always going to rise. Always. Okay, so no need to even explain why this comes about, right? While x is increasing, y is also increasing. So your y step is going to be positive and your x step is going to be positive as well. Okay, so that's going to be the case whenever you have a line that's rising. It's always going to have a positive gradient. Second thing that you need to know is that when a line is decreasing, it's going to be negative. So look at it. As x is increasing, as you are going in the increasing direction, y is decreasing. So meaning your y step is going to be negative when your x step is positive. So your overall gradient is going to be negative. Okay. Then the third thing that you need to know has to do with the steepness of a line. Okay. So if we were to pick a base line for our gradient, it would be a line with a gradient of 1, right? So whenever you have a line with a gradient of 1, it means that x and y are increasing at the same rate, meaning that it's going to fall right in the middle of the x and y axis, of course, right? Because they're increasing at the same rate, and the points that are going to be on this line are going to be 1, 1, 2, 2, 3, 3. The line is just increasing at the same rate, okay? So whenever you have a line that falls right in between the x and the y axis, perfectly between, it has a gradient of 1, okay? So this comes in because when you have a line which is closer to the y axis, okay? So that we'll try to break this down and actually understand why it's this way, okay? So when you have a line that's very close to the y axis, a much steeper line than your gradient of 1 line, it's going to be, just look at it, right? From this point to this point, y has increased by so much, but x has only moved a very small step, okay? So it means that your y step is going to be much, much greater than your x step. And what does this mean? When you're calculating your gradient, you're going to say y over x. So what does it mean when you have a fraction where the numerator is very big and you have a very small denominator? It means that you're going to have a number greater than 1, right? You're going to have a number greater than 1. So it means that if you have a line that's very steep as compared to your y is equal to x line, which is the line with a gradient of 1, then its gradient is always going to be greater than 1. Okay, and we'll go through a question that utilizes this concept. It just helps you to solve faster. You won't actually have to find the gradient of a line, but you can just approximate and you can be able to pick, because sometimes you'll be given a diagram, you'll be given a drawing of a coordinate plane, and then you'll be asked to choose what the equation of that line is. So if you're able to approximate what the gradient is, then you can be able to pick the right equation without actually calculating what the gradient is. Then if you have a line that's much closer to the x-axis, right, it's going to be the total opposite. Look at it. From this point to this point, your x has increased by so much, but your y has only increased by a very small amount. So now what happens if you have a fraction where your denominator is greater than your numerator? You're going to have an answer which is much less than 1. Okay, so it means that whenever a line is closer to the y-axis, it's going to have a gradient greater than 1, or in short, when it's steeper, it's going to have a gradient greater than 1, and when it's closer to the x-axis, it's going to have a gradient which is less than 1, and this will be very helpful. As I said, we'll look at a question that actually utilizes this. Okay, so that's about approximating the gradient. Okay, so at times you'll be required to also form a linear equation. And in that case, you would have to, there are two techniques that you can use to find the equation of a line. The first one is by plugging in. You looked at the general form of the equation of a line, y is equal to mx plus c. So if you can find your gradient and your y-intercept, you just need to put them where m is and where c is respectively. And then if you have 2 points on the line, this is an equation that you can use. This is actually the gradient formula. M is equal to y2 minus y1 over x2 minus x1, except that you make 1 point your unknown x comma y, and then you cross multiply. So this is a formula that's very helpful if you have 2 points and you're trying to find the equation of the line. Okay, then you also meet systems of linear equations. So there are 3 methods that you can use to solve linear equations. You have the elimination method, which is directly adding or subtracting the systems. Then you have the substitution method where you eliminate, you have the substitution method where you make one the subject of the formula in one of the equations and then plug it in. And then there's also plugging in. This is like a backwards method. So first of all, we'll focus on elimination and substitution. So the thing about the SAT is that you are really racing against time. So it's very important that you pick the method that's going to be faster for you. Okay, so you have to look at the system and be able to tell which method is going to be faster, elimination or substitution. And then you also look at plugging in. So elimination is the faster method if none of the coefficients in a system is 1. Okay, so this is just because dealing with fractions takes a longer time, right? If you have something like 3x plus 2y, okay, let's just imagine 3x plus 2y is equal to 3, and then you have 4x plus 7y is equal to 7. Okay, so if you have to make one of them the subject in either of those systems, you end up with a fraction because none of them has a coefficient of 1, right? You have to divide it by a certain number for you to make it the subject of the formula. So whenever you have a situation where none of the coefficients is 1, it would be faster for you to eliminate and not substitute, because if you make one the subject of the formula, it's going to be a fraction, and that would take you much more time to work through. So you're going to multiply the systems by a number which is going to get rid of one of the coefficients. So let's say you have 3x plus 2y is equal to 1, and then you have 4x plus 3y is equal to 2. So if you're dealing with such a system, you would have to come up, you would have to multiply both systems by numbers that would make you reach a point where the coefficients for one of the variables are equal in the 2 equations, right? So of course, it's easier to deal with smaller numbers as compared to big numbers. So if you are looking at such a system, it would be faster to eliminate y, because 3 and 2 are small numbers. We'd have to multiply the top equation by 3, bottom equation by 2. Then you can directly add or subtract so that you get rid of the y variable, and then you easily be able to find the x coefficient. And it's also important to watch out because most of the times, if you are, it's easy to tell which one can easily be eliminated, right? So if you're dealing with such a question, most likely they would ask you for the value of y. You get what I'm saying? They would ask you for the other variable. So it's important to pay attention to what is actually being asked, because it's easy to just find x, especially since you'll be rushing. Time is really not a lot, right? It's very easy to find the value of x and then put it as your answer when they're actually asking you for y. Okay. Then there are also times when you're going to have a system where the variables are already equal. It already has equal coefficients, right? So your work has been done for you. You would just have to use the elimination method without multiplying. So you go directly by adding or subtracting. So it is valid. There are times when you can directly add or subtract a system. That's if it gets rid of one of the values, or it directly gives you what you're looking for. So you have to pay attention. Look at the numbers in a system. Can you directly add or subtract? Because obviously that will save you a lot of time. Okay. So when you substitution the faster method, it may be faster if one of the systems, if one of the coefficients in the system is 1. So obviously it's easy. If I give you an equation like 2x plus y is equal to 1, you can just say 1 minus 2x, right? No fraction formed, very easy to do. So you can also use substitution, but it doesn't matter which method you use. It's just that you have to make sure that you pick the one that is faster. Okay. And then sometimes plugging in may be faster, especially maybe if you're not a fan of any of these two, or you don't really want to solve the equation, you can actually just look at your answers, because your answers have values, right, of either x or y or whatever is being asked for. Okay, so if you plug in, you can easily be able to find what the answer is. So when plugging in, it's very important that you're very strategic. You don't just plug in random values, because if you're just plugging in random values, there's a very big chance that you have to go through all of them before you find your answer. Okay, so the goodness about SAT math is that your answers are always going to be in order, either ascending or descending order. So when you're plugging in, and this concept does not only apply to linear equations, it's general in the math section. So it's good to start with option C. And there are many variations, by the way, this is just one. So if you start with option C, C is kind of your middle value. Of course, there's B and C. If you start with C, that's kind of your middle value. Okay, so if you plug it in, you're easily able to tell, because you're dealing with an equation, you can easily tell whether the value that you chose is too big or too small. In the end, you have to equate two values. So you can tell whether the value that you picked is too big or too small. So let's say we're dealing with a situation where these answers are in ascending order, starting from the smallest to the biggest number. If you start with C and you notice that it's too big, means you have to decrease. So meaning you're going to go to either B or A. And you can also approximate somehow. It's not always going to be accurate, but if you see that C is very, very big, then it would be best to go for A next, right? And if A is not your answer, then B is your answer automatically, okay? And then if you find that C is too small, D is automatically your answer. So it depends on how much you trust yourself. If you want to go ahead and prove it, like if in that situation where you see that C is too small, D is the only option that's big, and you really want to just be sure, then you can go ahead and plug in D as well. But the point is that when you're using this method, the maximum amount of times that you actually have to solve to find your answer is 2. And that's only if you solve C, C is not the one, and then you go to A is not the one, then you can go to B, right? But if you go to C, then you try B. If you go to C, then you try D and it's your answer, then you're done, right? So it's a very fast method. And when you're plugging in and you want to put your own numbers as opposed to using the answer options, as I said, it depends on the question that you're dealing with. So whenever you have to plug in, it's very important that you use answers that are going to give you the right answers that will actually show you properties that you can actually use, right? So it's not advisable to use 0 or 1. These are multiplicative identities. So most of the times they're just not good to use. And also using big numbers, like I said, will take you a long time to do. So it's best to use 2 or 3 or -2, -3, depending on the situation that you're in. Okay. Then there are types of equations that you have to familiarize yourself with when you're dealing with systems. So you can have dependent equations. So equations are called dependent if one equation can be obtained by manipulating the other. Let's say you have x plus y. Let's say you have x plus y is equal to 2, and you have 2x plus 2y is equal to 4. So you got the second equation just by multiplying that system by 2. Now, the thing with equations, of course, is that as long as you can reduce an equation and get another one, it's the same line. If you multiply a line by 2, it's the same line. Multiply a line by 7, it's the same line, right? So if you have a situation where you have equations that can be obtained by manipulating the other, the graphs are the same lines and they have infinite solutions. So there are times when you'll be given a system and then one of the coefficients will be unknown, and then you'll be asked, what value should B have if this system is to have infinite solutions? So you keep in mind that a system only has infinite solutions if it's the same line, meaning every single point on that line is the same. When you compare those two lines, you're going to have the same line. So it means that, okay, let's do an example. Let's say you have 2x, change this to a pen. Okay, let's say you have 2x plus 3y, don't mind the writing, is equal to 4. and then you have 4x plus by, so that's our unknown, is equal to 8. Now let's compare these two equations, okay? You have 2x plus 2y is equal to 4, 4x plus by is equal to 8. And then you've been told what value should b have if this system is to have infinite solutions. So what you're doing is you're trying to make these two equations equal, okay? So you're going to compare them and see what's the factor that's differing between these two, right? Of course, if you multiply the first equation by 2, you're going to get 4x and you're going to get 8, okay? So the difference is a factor of 2. So it means that for this to be equal, you should multiply 2 by the 2 here, which should give you 4. Then it means that you have equations, you have the same equations, and they are dependent equations, and they will have infinite solutions because they're the same line. Every point on the line will be equal to the other point in the line. So that's how you make two equations have infinite solutions. And then sometimes you can have a situation where you're told to find a variable if lines have no solutions. So it's important to understand when a line or when a system is going to have no solutions. Okay, so equations will have no solution if the same equation is equated to different constants. Okay. So the explanation for this is that if you have two lines that have the same gradient, but then they go through different points, right? They have the same gradient and they're going ascending at the same time, they're never going to meet. So that's where the basis of this rule comes from. The fact that if two lines have the same gradient, but they don't go through the same point on the y-axis, they're never going to meet because they are going to forever increase at the same rate or decrease at the same rate. So for equations to have, for you to have the same equation equated to different constants, it means that your m is equal, right? If you have y minus mx, we'll just move the x to the other side. You have y minus mx is equal to b. Okay, so what we're saying is this side of the equation is the same, meaning that you have the same gradient, they are rising at the same rate or decreasing at the same rate, and b is our y-intercept. So meaning that they are on different points of the plane. Okay, so if they have no constants, I mean, if the system has no solutions, it means you're going to have a different constant. So it means that you have to make everything else the same, but keep the constants different. Okay, so the question may come in the same form as the example that we had, where you have a system and you have an unknown. And then what your job would be to make sure that m is equal in both equations and b is different. That would be your job. Okay, so for fractional equations, clearing denominators by multiplying all terms by a number that will get rid of all denominators will make your work much faster. So in general, just working with fractions is a headache because you have to find the common denominator and then, so you can't just like go straight and solve the question. So let's say you have a question like 1 over 3 plus 5 over 6 is equal to 4. And let's say there's x and y somewhere in there. So for you to get rid of your denominators, you just have to multiply the whole equation by a multiple of both of these. So 6, of course, would be a logical choice. So if you divide 3, you're going to get 2. So the 3 gets cancelled out. And if you multiply there, also it also cancels out. So you're left with just a normal equation. Then, of course, you have to multiply the same 6 by the 4 on the other side. So it just makes your work much faster. So try to not deal with fractions as much as you can. Then just a random piece of information that might or might not help you, is that any line that is not parallel to any axis would pass through 3 quadrants if it does not go through the origin. I remember I once came across a question that required me to know this, which is why I added this. This is actually what I was using as my study guide. I just gathered all the key concepts and put them together. Okay, so the point is that if you have a line that First of all, if a line is straight, it only goes through 2 quadrants, right? But if it's slanted, it's going to go through 3 quadrants. Look at that. 1, 2, 3. A line like that goes through 3 quadrants. Okay, so any line that is slanted will go through 3 quadrants except when it goes to the origin, because then it would only go through 2 quadrants. Because the origin is your intersection point. Okay, so as I said, this might or might not help you. Might or might not help you. Might or might not meet a question that actually utilizes this. But just remember that any line will pass through 3 quadrants if it is not straight and if it does not go through the origin. Every line is straight, but I hope you know what I mean, parallel to the axis. Yeah. So these are the key concepts that you need to know. And so we'll go through an actual paper. Okay, so we're going to skip around. This is College Board Practice Test 1. So we won't really be solving them to completion. The main thing that I want us to do is just be able to analyze, understand the questions, and see what we need to do. So number 1, x minus 1 over 3 is equal to k, and k is equal to 3, find the value of x. Very simple question. I just want to bring out the aspect of you not having to write down all the steps. I know in high school, that's how I used to do it. I had to write down the equation again, and then solve the equation again. But you're dealing with time. So if you can solve it mentally, that would really be amazing, right? If you put a 3 there, right, you know it's 3 times 3, 9 plus 110. You've already found your answer. So it makes your work much easier just to write less steps down. But if you need to write steps down for you to keep track and get the answer right, please go ahead and do it. Just keep in mind that you don't have to write down the steps because you only need your answer. That's all they're looking at. Okay, so we'll skip to number 4. Says Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P is equal to 108 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. I hope this seems familiar. Okay, so what is the meaning of the value 108 in the equation? So it's an example of them testing your understanding of a linear equation in a real life situation. Okay, so remember what I said. You find that your x is time, and look at this, it's in days, right? So this is time. Okay, so this is time, but it's in days. There we go. This is time in days, and then P is actually what is being measured, which is the number of phones left. Okay, so look at this equation. It's in the form y is equal to mx plus c, except that the c comes before the mx. Okay, so 108 in this equation is our y-intercept. And remember, we said your y-intercept, whenever you see y-intercept, think initial, because the point when your time is 0, when x is equal to 0. Okay, so anything that implies that 108 is our initial is our answer. So we've been told that this is the number of phones she has left to fix at the end of each day. So if the day hasn't started, if you have 0 days, it means that she starts out with 108 phones. That's the initial. Okay, so that would be option B. Kathy starts each week with 108 phones to fix. I hope that's clear how we applied our y-intercept being our initial. So skip ahead to number 6, which is similar. It says the pediatrician uses the model above to estimate the height of a boy in inches in terms of the boy's age A in years between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of the boy's height each year? Okay, so look at this. It says, what is the estimated increase in inches of the height of a boy each year? Okay, so there's also a very important concept that you need to understand about gradient. Okay, so let me just make this a pen. Okay, so the thing about gradient is what you're doing is dividing your y step by your x step. And in doing this, you're finding your y per x. So the number that you find, let's say you find your gradient as 2, it means that for every 2 steps you move in the y direction, x moves 1 step because you're coming to divide. So whenever you see gradient, think y per x, because you are dividing these two, right? it will give you the number of steps that y moves for every step in x. So it's your y per x. So every time you see gradient, think y per x. Okay, so you have 3a plus 28.6. This is in the form y is equal to mx plus b, and that's of course our gradient 3. So it means that the height, our y, increases by 3 per x, and x is a, in this case, is the number of years. So it means that the height increases by 3 per year. Okay, so it's asking what is the estimated increase each year. It's going to be 3. That's the gradient. So that's what your gradient tells you. It tells you the number of units that y increases for every change in x that you make. Okay, we'll skip ahead to number 12 just because I know it's coordinate geometry, but it has a very important concept. Then we'll go back to number 9. So number 12 says a line in the xy plane passes through the origin and has a slope of 1/7. Which of the following points lies on the line? So we said if a line goes through the origin, for you to find the gradient, it's just going to be y/x. So there's no need for you to have another point in the line or anything like that. No need for you to find a complicated way. I'm sure there is a complicated way to find the point, find another point on the line. But then all you need is just the coordinates of a point, right? So how do you know if the point is 1/7? Just go through and try y/x. 7/0, no. 7/1, no. 7/7, no. 2/14, yes, can be reduced to 1/7. So that's a very good concept to have. Number 9 says, what is the solution x comma y to the system of equations above? Okay, so looking at this, remember we said you have to see which one would be the best method for you to use, substitution or elimination. Okay, so looking at this, we have 2y minus x is equal to -19. It would be really easy to substitute the second equation, make it the subject. So take x on the other end and bring -19 and then plug it in. But if you prefer elimination, that wouldn't be too far either, because you just have to multiply the second equation by 3. That's all you need to do. Okay, so there we go. You just need to find which one is more convenient, or even which one you prefer. Just whichever one you feel would be faster. Skip to number 18. Also, an equation, very important concept here. It says, according to the system of equations above, what is the value of x? Now look at this, okay? X is equal in both. And remember what we said, you just need to directly subtract and you get rid of the x and you find the value of y straight away. But what are they asking you? Value of x. So here you just need to be very careful in solving. It means that you would have to, if you were going with elimination, you would have to subtract the two equations, find the value of y, and then plug in to any of the equations to find the value of x. But since you are being asked for x, it would also be a good method to just use elimination, multiply the top equation by 2 so that you can eliminate y, and then just find x straight away. So it doesn't matter which method you use, as long as you have the right concept in mind and you keep you know which variable is being asked for. So skip to calculator. And we will look at question 15, also coordinate geometry, but lines. So look at it. It says, the graph displays the total cost C of dollars of renting a boat for 8 hours. And you have the line, and it asks, what does the C-intercept represent in the graph? Okay, so what is our C total cost, the y-axis? So C-intercept is our origin. Is our initial. Remember, when you see y-intercept, think initial. Okay, so what would it be? It would be the initial cost of renting the boat. So it's the cost before the hours start moving. So it's the base payment that you have to make before you can actually go out with the boat. Then 16. Okay, so this question is very important because it brings out the method I talked about approximating your gradient. Okay, so it asks, which of the following represents the relationship between H and C? Okay, so if you look at it, two things that you can get just by looking at the graph. You can get your M and your C. Okay, your C is your intercept. Of course, it's 5. So it means you're only dealing with options B and C. They're the only ones that put the right y-intercept where it's supposed to be. So next is your gradient. Now look at your options. You have a fractional gradient, which is less than 1, and the whole number gradient. Okay, so what you have to do is see, compare the steepness. So at first glance, if you look at this line, it's not really easy to tell whether it's closer to the x-axis or the y-axis. But look at the units. The units are not really equal, right? So for you to sketch a line, you just need 2 points, right? So if you want to sketch a y is equal to x line, look at where 2, 2 is, approximately there. Draw this line. Very clear now, right? This is very steep compared to that line, meaning that it has a whole number gradient. So it's going to be 3. That's your answer. Okay, so if you want, you can prove it. You can try to calculate it and see, but yeah, definitely going to find 3 because this line is steeper, meaning it has a greater y step compared to the x step. So I hope this video was helpful, and if you're new here, don't forget to subscribe so that you don't miss out on the rest of the series. Also, I would love to hear from you in the comments down below. Thank you so much for watching.